Assalamu alaikum. Table 1 guidelines for interpretations of water quality for irrigation. This is a FAO table, very important table concluded by FAO to help us evaluating the quality of water for irrigation. The FAO summarize what we have mentioned from previous part of the lecture. As I told you, the FAO depend on four problem can be found on irrigation water. The first is salinity, the second is infiltration rate or infiltration problem. The third is specific ion toxicity. The last problem is miscellaneous effect. Let us start with salinity. Salinity, as you know, that salinity can be presented as electrical conductivity and in DC Siemens per meter. And if you have the EC less than 0.7, then you have non-degree of restriction in use. However, if the salinity between 0.7 to 3, you will have slight to moderate degree of restriction in use. If the salinity more than 3, then you have severe degree of restriction in use. You can convert the EC to total dissolved salt by multiplying the electrical conductivity on 640. If you multiply 0.7 on 640, you will get 448 or approximately equal to 450. So if you have salinity concentration on irrigation water less than 450 milligram per liter, then you have non-degree of restriction in use. If the salinity between 450 to 2000, then you have slight to moderate degree of restriction in use. If it is more than 2000, then you have severe degree of restriction in use and should be avoid to use this type of water if the TDS is more than 2000 or electrical conductivity is more than 3, then you have to avoid this type of water to irrigate sensitive salinity crops. But you have to irrigate here is a tolerance crops like barley and or tree like date palms, olive tree, and so on. Infiltration problem, as I told you before, that the infiltration is related to two parameters. The first is sodium, which is represented as SAR, and I told you that SAR equals the concentration of sodium over the root of calcium plus magnesium over 2. So if you calculated the SAR and found it from 0 to 3, if the AC is more than 0.7, you have non-degree of restriction in use. But if it is 0.7 to 0.2, you have slight to moderate degree. If it is less than 2 point, you have here severe degree of restriction in use. Here, if you have SAR 3 and salinity is less than 0.2, you should add a source of calcium to increase the ratio, to decrease SAR and to avoid solidification of the soil or converting the soil to sodic soil and consequently decrease the infiltration rate. So if you have fresh water like this type of water, then you have no problem, just to add gypsum with irrigation water. You can observe here clearly that when the salinity increases, then the degree of restriction in use decrease. When salinity increases, the degree of restriction in use with respect to infiltration rate is decreased. But if you have a high SAR with low salinity, then you have a severe degree of restriction in use with respect to not salinity but to infiltration rate, and you have to solve this problem just adding a source of calcium to solve the problem. Then infiltration problem here, in the presence of fresh water, easy to solve. However, if you have a saline water, it's not easy to make a desalination, because desalination is cost, energy, and economically not feasible to desalinate saline water and use the desalinated water in irrigation. But here, if you have a problem of infiltration rate, it's easy to solve by gypsum addition. And if you look here, if you have a SAR from 20 to 40, not 0 to 3, from 20 to 40, but you have a high salinity more than 5, then you have no problem, no degree of restriction in use. But if you have this high value of SCR with low salinity, then you have a problem, severe degree of restriction in use. How you can solve this problem? By addition of gypsum. The third point is specific ion toxicity. As I told you, that FAO concluded that usually there are 3 toxic ions in irrigation water, usually found in irrigation water. These are sodium, chloride, and boron. If you look to the sodium here, the toxicity of sodium is differ depending on the type of irrigation. If you are going to irrigate using surface irrigation, then the SAR your SAR is less than 3, then you have no degree of restriction in use. But if you have the SAR between 3 and 9, you have slight to moderate degree of restriction in use. If it is more than 9, then you have severe degree. In sprinkler irrigation, avoid use sprinkler irrigation if you have a concentration of sodium more than 3 milli equivalent per liter, because in case of using sprinkler irrigation, the droplets of water fall into the leaves and absorbed by leaves, and then the toxic ion accumulate directly to the leaf, causing a damage to leaves and plant. So in case using sprinkler irrigation, avoid using saline or water contain toxic ion like sodium or chloride or boron. Sodium or chloride especially, because it can be make as I told you, can be accumulate on the leaf. Chloride, if you have chloride in surface irrigation, should be less than 4 milli equivalent per liter. You have no problem. But if it is more than 10, then you have severe degree of restriction use, and you have to select a tolerant crop for chloride. In sprinkler, avoid using the water in irrigation by sprinkler if you have the chloride concentration more than 3 milli equivalent per liter. For boron, if it is its concentration less than 0.7 milligram per liter. Milligram. Here is the unit is milligram. There is milli equivalent. The milli equivalent is bigger unit than milligram. If you want to convert chloride from milli equivalent to milligram, you have to multiply on equivalent weight. And here you have, for example, if you have 3, you should multiply in 35 to get milligrams. So the unit here, so I would like you to imagine that this concentration a plant can tolerate in the high quantity for chloride and sodium, while here in traces of barium, if you have traces of boron, the toxicity may be conducted. So if you have a boron concentration from 0.7 to 3, you have slight to moderate. If it is more than 3, then you have severe degree of restriction in use. And avoid to irrigate this type of water. If the concentration of boron more than 3, avoid to irrigate a fruit tree, because it may accumulate boron and make a toxicity to the plant. Trace element, the most important trace element may cause toxic to human, not a plant, is a cadmium. A cadmium is considered a toxic element to human and cause kidney dysfunction and may be other problems to human health. However, the cadmium may accumulate on plant and do not cause damage to it. The problem on cadmium, that it may accumulate on plant and the plant can survive, but when the human take this plant and eat it, the boron can cause problem to the human. Miscellaneous effect. The first one is nitrogen as a nitrate. If its concentration is more than 5 milligram, no problem. If it is 30, then you have severe problem. One can ask me that the nitrate is a macronutrient, and usually farmers add nitrate as a fertilizers. How can be toxic? Excess amount of nitrate can be toxic for plant because it may lead to increase the vegetation, increase the vegetation while decrease the yield, and increase also the growth of the plant, and can also the excess amount of nitrate may leach to the groundwater and make contamination. The third miscellaneous effect is bicarbonate, and its concentration should not be more than 0.5, especially if you are going to use over sprinkler irrigation. But if it is surface irrigation, no problem with respect to barium, because it may cause on-site effect to the leaves and reduce the quality of the yield, especially if you are going to plant leaves eats crops. The last parameter is the pH, and the normal range of pH is 6.5 to 8.4. More or less of this value will be unacceptable for irrigation. This all for today. I hope to understand this lecture. This lecture is important because here you understand how we can evaluate the quality of water and how can interpret the analysis of water if you have any analysis and has been asked to make an interpretation. Thank you.